Okay, so today, net ionic equations are basically equations that only show what precipitates or what drops out of solution. So these are always going to be double displacement reactions that you're dealing with. What you're looking for is whatever is the solid. So to make this solid, we needed silver and chloride. And so when you do the net ionic equation, you're showing only those ions. So the net ionic equation looks like this. So we want to take our silver ion, because it's an ionic equation, we show the ions, plus chloride, and it makes AgCl as a solid. That means that I still had sodium and nitrate that are floating around. We call those spectator ions. So they kind of watch the sodium chloride drop out. So spectators are what don't precipitate out. So that would be sodium and nitrate in this case. So this is just showing that the only things involved in the net ionic equation are the ions that form the precipitate, and you know that it's a precipitate because it's solid. So for this, here's what we know. In the photograph, we have iron 3 chloride and potassium hydroxide being mixed. So that's what's in this container right here. A precipitate, so we're told what our precipitate is, of iron 3 hydroxide forms. So what we have, if we take iron 3 chloride, so that's FeCl3, our ions are iron 3 and chloride. And if we take potassium hydroxide, that's KOH, our ions are potassium and hydroxide. And we're told that our precipitate is this iron 3 hydroxide, which means we're going to combine this ion, and that's what this precipitate dropping out is. So when we do a net ionic equation, we're going to take our iron 3 plus hydroxide, and we're going to combine it to show that it forms a precipitate of FeOH. Oh, shoot. Sorry. FeOH3. And that is a solid. So we want to balance this, which means because we needed 3 hydroxides to make our compound, we put a 3 here and now we're balanced. So that leaves us with the spectators of what's left. So my spectators here are potassium and chloride. All right, so we need to be able to identify what's actually going to precipitate out, what's going to drop out of solution and become a solid. So if it's soluble, so what this word right here is talking about, if it's soluble, it stays suspended. You will have this table on the right as part of your resources for a test. Basically, it's divided up by the very first box here is dealing with the cation, or what that compound starts with. And these are always ionic compounds. These boxes down here deal with the anions. And so I'm going to show you examples of each. So basically, if it's an alkali metal, which if you remember, alkali metals are group 1 metals. So for potassium sulfate, potassium is group 1. So it's going to stay dissolved, it's soluble. Sodium, group 1, it's going to stay soluble. Lithium, group 1, it's going to stay soluble. Hydrogen, group 1, it's going to stay soluble. So all of these are soluble. They're never going to form a precipitate. So if we look at the second rule, this rule deals with nitrate salts and chlorate salts. So I put in what nitrates and chlorates are right here, and then I created some compounds. So we're just going to go through and see if there's anything that's not soluble here. So if they end in nitrate, they're always soluble. There are no exceptions to this rule. Potassium chlorate, soluble, no exceptions. Magnesium nitrate, soluble, no exceptions. Iron nitrate, iron 3 nitrate, soluble, no exceptions. And calcium nitrate, that should have been a 2 here, also soluble because it's not an exception. So the first two, basically you have no exceptions. If you have an alkali metal or if your anion is nitrate or chlorate, it's always going to be soluble. The rest of the rules deal with what are the exceptions. So if we have sulfate salts, basically any sulfate salt is soluble unless it is combined with lead 2, silver, mercury, that's a typo right there, barium, strontium, and calcium. So I have a whole bunch of sulfate salts. Calcium is one of my exceptions. Looking down, silver is one of my exceptions. Okay, so as far as soluble or not, so these are all sulfates. This one is not soluble, which means it will precipitate out. So it forms a precipitate. Same thing with silver sulfate. It's one of the exceptions, and so it will precipitate out. But everything else is going to stay soluble. It's going to stay dissolved. All right, for chloride salts, your exceptions are if you have silver chloride, lead 2 chloride, or mercury 2 chloride. So if we look, this one is soluble. One, it has a group 1, an alkali metal, so it's always soluble. So that one is going to be soluble. Silver chloride, it's one of the exceptions. So silver, it is not soluble. So it's going to drop out. It's going to form a solid precipitate. Then we have lead chloride. Well, lead was one of our exceptions. Also not soluble. It will form a precipitate, which we indicate as a solid. Iron chloride, that one's good. So let me just mark. Lead was an exception. And then mercury chloride. All right, again, it's an exception. So not soluble, which means it's going to drop out as a solid. And then potassium chloride, it's soluble for 2 reasons. It's not an exception and it has an alkali metal. All right, the last rule takes a whole bunch of different anions. So this whole group right here, carbonates, phosphates, chromates, sulfides, and hydroxides. So anytime you have any endings like this, the only time they're soluble is if they are with an alkali metal. So alkali metals are soluble in any of these compounds, nothing else is. So if we look on any of these endings, carbonate or phosphate or hydroxides, any of these are going to be insoluble unless they're with a group 1 alkali metal. So here's an alkali metal, that means hydrogen carbonate is soluble. Here's another alkali metal, so that means sodium phosphate is soluble. Potassium is an alkali metal, so that's soluble. Everything else on here is not. So this one is not, so it's going to precipitate. This one is not, it's going to precipitate. This one is not, it's going to precipitate. This one is not, it's going to precipitate. And again, this one is not, it's going to precipitate. All right, so putting it all together, we have several examples here. So if I've got ferric hydroxide, so I look pretty much if it's not alkali, first thing I would do is I check for alkali. So this one's alkali, this one's alkali, this one's alkali. Those are all going to be soluble. So I'm going to check the rest. For hydroxide, all right, hydroxide is this rule right here. Here's my hydroxide. This is not. It's going to drop out, precipitate. Sulfate is my next one. So I'm going to look at my sulfate salts. And silver is an exception. So this one is not soluble. It will drop out as a precipitate. The next one I'm looking at my anion chloride. So I come to chloride salts. Lead is an exception. It's not soluble. It's going to drop out as a precipitate. For magnesium, so I have chloride again, but it's magnesium. It's not one of my exceptions to the rule, so it's going to be soluble. It's going to stay dissolved. Magnesium sulfide. So sulfide salts are down at the bottom. Magnesium is not group 1, so it is not a soluble compound. Oh, I missed an alkali metal. Sodium hydroxide, definitely soluble. So soluble, soluble. Okay, hydroxide again. So hydroxides are the ones that the only time they're soluble is with alkali metals. This one is not. Silver is not an alkali metal, so it's not soluble. For nitrate, all right, remember all nitrates are soluble. It's going to stay dissolved. For mercury sulfate, so mercury, one of the exceptions, it's not soluble. And then we already talked about alkali is always soluble. So that's how you tell what's soluble and what's not. You will have access to this chart, so you'll want to know how to use it. So if we have this here where we're asked what will precipitate out of all of these ions, well, we know we're going to have spectators and we're going to have our net ionic equation. So what I always do is look for alkali first. Okay, sodium's alkali, it's going to go under spectators. Done. I'm done with that one. Now I've got nitrate. That's, remember, everything's soluble with nitrate. It's going to be a spectator, so NO3 minus. Now I want to check barium and carbonate. So I find my rule with carbonates. It's this last rule right here. It's not soluble because barium is not a group 1 metal. So that's going to form my net ionic equation. I'm going to take a barium ion plus a carbonate ion, combine them, and I get BaCO3 as a solid. And so that's what this is showing here. What I added, which is one thing you're asked to do, is find the spectators. So the spectators are the other ions that are involved. All right, hopefully that's enough to help you understand. Your homework, this right here, is based on what I just covered. And then the study guide you'll need to get a handout for. All right, thanks.